Hey everyone, welcome back to another video of mine, where today we're going to be solving Leetcode problem 3 titled Longest Substring Without Repeating Characters. So we're given a string S, and we simply need to find the length of the longest substring within that input string S without repeating characters. Okay? So pretty simple, concise, and clear problem statement, especially compared to some other problems that I've covered on this channel, and so this shouldn't be that bad of a problem. So let's just go ahead and visually depict this within the examples. So in example 1, we have an input string S of ABC, ABC, BB, and our output would be 3 because that is the length of the longest input or longest substring within our input that actually doesn't have any repeating characters. And that substring that has that longest length of 3, in this case, is going to be ABC, right? Because of course, both all C, B, and A, they all have a frequency of only 1. No more than 1, no less than 1 in our input string, or in our substring rather, and so that's why we'd output the length of that longest substring that doesn't have any repeating characters, which in this case would be 3. So in example 2, since we really literally only have one element that's being repeated for every single index in our input string, we simply only output 1 because any substring that we actually choose, it's only going to have a length of 1, otherwise it has repeating characters, so of course we'd only output 1. So in example 3, we have an input string S of PWWKEW, and our output would be 3, right? Because the answer is WKE, which is the substring that has the most amount of non-repeating characters, that also has a length of 3. But you can also notice that the answer must be a substring, so PWKE is not going to work, because PWKE, that is a subsequence. That's not a substring, and basically what a substring is defined is, it's basically contiguous within our input. A subsequence does not have to be contiguous, but rather simply containing elements from different positions or different index, as long as it's actually within our input, right? Of course, we can't actually output the longest subsequence without repeating characters, but rather the longest substring, right here. So that's also something that you have to keep in mind. Okay, so I will give you guys a few seconds to kind of just go over this problem in your head and try to think of a solution that's optimal. And if you guys can't solve that, that's completely fine. I will go over how I would optimally solve this problem in a few seconds. Okay, so this is actually a classic problem for the two-pointer or sliding window algorithm, where you're basically keeping track of a current longest length that you've seen so far for any window that you've encountered within your input string, right? And you keep updating that bit as you find more valid, longer length substrings or windows from our two-pointer algorithm within our input string S. So before I actually start coding this up and explain how I do so, let me actually just zoom in a bit so you guys can kind of see. Actually, I think that this should be fine, right? So let's talk about how we're actually going to deploy our two-pointer algorithm. So we're going to use left pointer, kind of like in binary search, to start at the 0th index, and our right pointer. Oh, sorry, guys. 1 second. Okay, and our right pointer is basically going to be. And our right pointer is basically going to be used to expand through the input string. We're going to be automatically expanding it rightwards with a loop, right? As R is our iterator, and we'll do this like so. We'll have our left pointer. I could call it left, but just for the simplicity of this code, I'll just simply call it L, and that's going to be 0, as we talked about just now. And then I'll actually have a longest, right? And like the longest variable is simply going to monitor and keep track of the longest length window that's actually valid within our string S that actually we've seen so far, right? So of course this is also going to be initialized to 0 because we haven't actually iterated through the array yet. But there needs to be a way that we can actually validate our window and actually see if it has any repeating characters or not. And the way we do that is actually to keep track of all of the elements that we currently have in one specific window or one specific iteration of our input string S. And how do we do that? We can simply say, let's just call this current set, right? And this is simply going to be initialized to an empty set that we ultimately will be adding characters to based on if it's a valid window or not, and simply monitoring the length of this window and updating the longest if the length of this number of valid elements that we've seen, this actually substring, is greater than the longest that we've recorded so far within any of our encountered substrings or windows. So now that we've really initialized all of our variables, let's actually use the R iterator or the R second pointer to actually automatically loop through and expand forward rightwards our window, right, using the for loop. So we'll say for r in the range of the length of s, or basically the indices of s, let's actually first invalidate our window. First, let's check if we actually have any duplicate characters, and while that is actually true, while we actually have duplicate characters, let's move our left pointer one to the right and keep doing that until we don't have any duplicate characters left. And instead of using an if statement here, because we could always still have more duplicate characters than just one, we'll actually just use a while statement to cover every single instance or iteration that we actually have duplicate characters within our current window. So we'll say while s at r, or basically while the element that we're actually adding in our current set that stores all of the elements in our current window, or substring, while s at r is actually in the current set, or basically the current set that monitors all the elements in this specific window, while that's actually true, that means we have an invalid window, and we actually have to move our left pointer one and remove the one that's actually at our left pointer, or the elf indice. So current set dot remove s at that elf indice to kind of just take away and move right, and then we'll increment our left pointer by 1. And we'll keep doing this and removing the leftmost element and right until we don't have any more duplicates. Right? And after we exit that while loop, now we'll basically have had a valid window, and at the end of that, we can actually just add s at r to our current set while we actually don't have a valid window. We can work on that in the while loop. So we'll say current set dot add s at r, right? And so what this is basically saying is within our for loop, but outside of the while loop, we're basically adding every single s at r in our current window or in our current set. But while s at r is already in our current set, we have to remove s at l, or the leftmost value, and increment our left pointer by 1 and keep going to the right, or expanding our window right in the left pointer's information until we don't actually have any more duplicate elements. Or basically, while s at r is actually not in our current set. So basically, the current element that we're adding to our current set that monitors all the elements in our current window, while it's actually not in the current set. So while it's basically a new element and a non-duplicate value, we can add it to our current set without actually having an invalid window. And now once we've actually done this and monitored all those different possible windows with no duplicates, we can simply literally just set our longest to be the maximum value of course, its longest, and then, of course, the window that we're currently looking at. But how do we actually get the window that we're currently looking at, right? How do we actually get the length or the number of elements in our specific window or this specific iteration? And we'll do this like so. Let's say I have an input string of 1, 2, or I'll say A, B, C, D, D. So I'll have started my left pointer at 0, right? And of course, my R pointer is going to be iterating and automatically going through the array or expanding through the input string. So I'm going to have a left pointer initialized to 0, right? I'll use my R pointer to basically loop through every single element in A, B, C, D, D and add it to my current set, while s at r, or the current element that I'm adding to my window, is actually not in our current set. So basically, it's a non-duplicate value. So I'll use my R pointer and I'll add s at r, or basically A, to my current set. Then I'll add B. Okay, and then I'll add C. Oh, sorry. Then I'll add C. Then I'll add D. But now, once I add this first D, I have to go to my second D, right? S of R is going to be basically at index 0, 1, 2, 3, 4, 4, right? At index 4, or basically the second D in this input string S, right? Well, let me just set this equal to S. So now, S at R is actually already in our current set, right? Because we already have just added a D to our current set just now. So what we want to do is we want to remove S at L, or basically this A, from our current set, and then increment by 1. So basically, while S at R is still in the set, we'll move to 1. Okay? And that's basically how we'd visually depict this. So once I've set my longest to be the maximum of the longest itself, I actually have to set it to the maximum of the longest, and of course, the window length. And the way I get the window length is simply subtracting the indices from each other, so R minus L, and then adding 1 to that difference. You may be wondering, okay, I understand the subtracting indices to get the window length, but why do we add 1? And that's because indexes are actually 0-based, right? And what this actually means is, if I were to have an input string of A, B, C, D, let's say, of course, this is already a valid window because it doesn't actually have any repeating characters. So if this was basically the window that I'm returning, I would set the longest equal to the maximum longest window length that we've recorded so far, and of course R minus L plus 1, which is defined as the window length for one specific window. So R minus L plus 1, let's actually just compute that. R would be at index 3, right? 0, 1, 2, 3, because indexes always start at 0 in programming. So R is at index 3, and A is at index 0. Now, we already know just by looking at this input that, of course, it has a length of 4, but how do we actually compute that for the computer, right, when it's a lot larger of a length? So R is at index 3, and A is at index 0. So basically, the length of this window is going to be R minus L plus 1. We have to add the 1 to actually count for that 0 index starting. So R minus L plus 1. R is going to equal 3. L is basically A, so I'll just put this to A. L is basically going to be 0, and we'll add 1 to account for that 0 index starting. So 3 minus 0 is 3, and 3 plus 1 is basically going to be equal to 4, which does indeed match the length of ABCD. Okay, so once we've set the longest to be the longest or maximum of itself and the window length for any valid window that we actually have, as denoted by line 8, then we can literally just simply return longest, because ultimately it will have stored the longest possible window length for every iteration of our R iterator, or basically for every iteration of every possible valid window that we actually explore without repeating characters within our input string S. And as you can see, it's just about as efficient as you can get. Time complexity-wise, it is actually a linear time solution because we're really only looping through the array once, and so it's O of n. And memory complexity-wise, of course, is going to be the minimum value of m and n, right? So, if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. It really does mean a lot, and I hope you guys learned something new. Without further ado, I will see you guys in the next video. Bye-bye.